started on our wonderful talk schedule. And we are so lucky to have Sarah Al-Ahmed from the Planetary Society and Planetary Radio to come talk to us about planetary radio conversations with the people searching for other worlds, exoplanet seekers. So come on up here, Sarah. I know Sarah really well. She worked with me at Griffith Observatory for a lot of years and made the show I do there, All Space Considered, better and better and better. And then she left and we got worse for a while. But we figured it out. We did. But the Planetary Society gained from that. And I recommend that you all look into joining the Planetary Society if you care about advocacy and making sure that space and science is still there for us and we're still doing the research. Listen to Sarah. So thank you so much for being with us here today. And Sarah Al-Ahmed, everybody.
I tell you, it is such an interesting thing to, after so many years of working at Griffith Observatory with Dr. Reitzel and the other wonderful people there, to be able to do my own show. And also, shout out to my high school boyfriend for buying me a star that I still have. I know, right? You know, it was a romantic thing to do for a young person that really loved space, right? I value the idea. So as he said, I am Sarah Al-Ahmed. I am the host of Planetary Radio at the Planetary Society. Planetary Radio is a show that we do once a week. So every Wednesday, I get to talk to people about space. And that can be everything from space advocacy, the exploration of other worlds, missions that are just being launched, new telescopes. I have the wild privilege of being able to talk to space people all over the world every single week. So I really am living the dream after all of my time working at places like Griffith Observatory, which I'm sure most of the people in this room have been to. But if you haven't had a chance yet, please go up there and check out that place. It is one of the most beautiful observatories in the world. So we have kind of three different versions of Planetary Radio going on right now. We have the original Planetary Radio that was started over 22 years ago by my colleague, Matt Kaplan. So we have a 20-year plus backlog of episodes you can go through to learn more about space things. But we also have an edition that we do once a month called Space Policy Edition. That comes out on the first Friday of every month. That one is dedicated mostly to space politics in the United States. And as you heard earlier with Judy Chu, right now is a really important time in space policy. We're working really, really hard to try to maintain the funding for NASA science, which is being cut by about 47%. That represents about 40 plus missions that you may know and love, right? Many of which were made over here at JPL, but it is so far beyond that. Even the ones that you may remember from 46 years ago, the Voyagers are also on the chopping block. Juno, Osiris, Apex, a bunch of upcoming missions. So if you want to know more about that process, highly encourage you to check out Space Policy Edition that's hosted by my colleague, Casey Dreyer. But we also just launched our new book club edition. So if you're into books about space, or you like books like The Martian, our first episode that just came out is with that author, Andy Weir, about his book, Project Hail Mary. And they're coming out with a movie about that pretty soon. So that's where we decided to start. But that's going to be coming out on the third Friday of every month. Through my job, I get to go on all these wacky adventures, right? I have been to host NASA conferences, interview people who are pretty famous in astrophysics and space. You can see me here interviewing Neil deGrasse Tyson. I got to help produce a Star Talk episode, but also interview British scientists, people from all around the world. It is a wild privilege. And also, I've been to Washington, D.C. a few times. So I got to meet Judy Chu, talk about the Planetary Science Caucus, and also go with space advocates to go talk to people in Congress about why this stuff matters to us so much. So I can't even describe to you what my last few years have been like. Prior to me being on this show, I was an avid space fan and a science communicator, but I've only been at this for about 2.5 years. And you can imagine after doing a show every single week, you get to know a lot of people. And the people in space are some of the kindest, most inspiring humans I have ever met. Our show is created by the Planetary Society, and you heard Dr. Reitzel speak a little bit about that, but the Planetary Society is the world's largest and most effective nonprofit dedicated to space exploration, the advancement of space science and exploration around the world. And you may recognize some of these people right here. These are our founders. So right there is Carl Sagan in the middle. He's rather famous from a television show called Cosmos, but also from all of the work that he did and the other books that he wrote. He was one of the first popular science communicators and a big inspiration to me and my family. When I was too young to even be able to speak, my family was showing me Cosmos, right? But his two colleagues, Bruce Murray and Lou Friedman, all three of them got together and decided they wanted to form the Planetary Society. This was a moment in human history right after the Apollo program ended. After humans went to the moon, we saw people bouncing around up there. It inspired an entire generation of people. It inspired the whole world to want to get involved in space exploration. But right after that, after the missions to the moon ended, suddenly the will to fund space exploration dropped right through the floor. Congress decided they wanted to cut the funding to NASA quite dramatically. And you will note we have not sent humans back to the moon since then, right? The funding decrease during that time led to a massive brain drain. That's not to say that we completely lost our ability to know how to go to the moon. Clearly, we still have that capacity. We lost so many of the people that did that work during that time. And we're seeing a lot of that happening today as funding is scaled back from these things. Many people are being forced out of the field, and I can't even imagine the consequences of all those brilliant minds that are going on to other things and losing that context. So in that moment, these three people got together and decided what we needed was a grassroots organization so that people all around the world could get together and try to speak out for funding for space, and to help dictate things like the decadal survey, to bring scientists together to try to think more about what our priorities were collectively. Now, clearly that's a whole separate group, but many of our board of directors are on the panel that creates that decadal survey. And we're international. We've got 50,000 plus people from around the world that work on this. Today we're run by, you may know this guy, that's Bill Nye, the science guy. He's our most recent CEO. And that's me and my brother. We were all at the Eclipse last year. You'll note I'm wearing the same exact outfit because I love this dress. But I got it for the Eclipse. These moments of space that bring us all together, it's something inspiring to behold. And it is such a wild thing to be able to work with someone like Bill Nye, who was one of my mentors, or one of my aspirational figures when I was younger. Now, what we do is we do these three things. These are the three pillars around which we organize our efforts. First off, we want to try to defend our planet from asteroid impacts or other things that could hit our planet. Now, in order to do that, we need scientists to be able to look out and find those objects so that we can then try to do things like deflect them. You may know recently we had our first attempt at trying to smash into an asteroid, the double asteroid redirection test, the DART mission. That was my first space launch ever. So we are making inroads on this process, right? We're beginning to understand how we can smack into things and hopefully save our planet, because as far as we know, this is the only world that has life on it. Of course, if we know more about exoplanets, eventually someday we'll be able to answer more of these questions. And hopefully we're not the only world that has life on it. I'm going to skip the middle one because we're going to come back to that in a moment. Our third pillar is that we want to find life. Now that is a process that can include exoplanets and does, but we're not at the point yet where we can necessarily tell you there's life on those worlds. So we're beginning with the things that we know in our own solar system. In this image right here, it's a part of, well, that little thing right there, this is not an actual image, okay? This is an artist's impression, but that is the Cassini mission that went around Saturn. It's flying over a world called Enceladus, and you'll notice there are all these jets coming out of this world. That's because this is a moon in our solar system that has a subsurface ocean beneath a sheet of ice. And in that, in the ice sheets, there are cracks, and the water comes out through those cracks. And when Cassini flew through them, it found evidence that there are hydrothermal vents down there, that there is liquid water, clearly, and it found things like phosphorus, which I'll talk about a little bit later, but that is one of the key chemicals for life on Earth. So finding life is both a process of trying to understand the worlds beyond our solar system, but also trying to figure out the situations within our own solar system that these things can exist. But the thing that we do most is we advocate for the exploration of worlds. It is our core central pillar. We want to know more about the worlds in our own solar system, but also about the worlds beyond. And that takes a wild amount of advocacy, but also a lot of science, as we've heard from many of the people here. So we begin with our solar system, clearly not to scale, but we begin with the worlds that we know. And once we can understand more about the worlds in our solar system, then we can project outward and apply those things to the other worlds. So what about the worlds beyond? We cannot see planets outside of our own galaxy. We have to start with the ones that are actually in our galaxy, but that is a whole process that we are only just beginning. I got my start in astrophysics as a tiny, tiny child. I was very young when this exoplanet was announced. We heard a little bit earlier about some of the earliest exoplanets that were discovered, the ones around pulsars and things like that. I was, I believe, in second grade when my teacher came to school with a newspaper clipping, and it said that we had discovered a planet outside of our solar system. Prior to this, I was absolutely obsessed with space. I had many, many books about all the Voyager images and things like that. My brother was all dinosaurs, and I was all like Venus, right? But it wasn't until this moment when someone said to me, there are worlds beyond our solar system. There are worlds orbiting other stars. I was so obsessed in that moment that I went home and I immediately told my mom, I'm going to study space. And I'm pretty sure they thought I was going to grow out of it, right? I mean, I was a tiny child, but I didn't grow out of it. It was an obsession. This world was a seed planted in my brain that did not let go. And I spent the rest of my life chasing it. I went on to get my degree in astrophysics at UC Berkeley, but woo, Berkeley! But you can see on the right-hand side of this is a picture of me in the basement of Campbell Hall at UC Berkeley. It has now been demolished and rebuilt, but this is the astronomy building on campus. And in the basement, they have a well of computers that connect to telescopes around the world. And during that time, I was working trying to find exoplanets. I had finally learned enough science to go on to actually try to accomplish this dream. It was awesome, but you'll note this was before Kepler was fully doing its thing. This was before we had tests. We literally had to find planets one at a time, staring at these transits as these planets went around. I'm particularly fond of this exoplanet, HAT P1b. This was the first one that I got to work with, although it had already been discovered before I got there. I got to be part of the undergraduate crew that did the work to try to find other observations of this thing. And I literally spent, I don't know, 6 months trying to code my own differential photometry program so I could see the dips in the starlight from the data that we took from Lick Observatory, which is up above San Jose. It's actually the oldest observatory in California. I think it was built in 1888. The first time I went up there to try to actually take data on this telescope, not only did I get liquid nitrogen on my foot because I was wearing flip-flops trying to fill a dewar with liquid nitrogen. Even in astronomy, always wear your safety gear and closed-toed shoes, okay? I learned this lesson the hard way. But I also went up there and I asked the people, why did you build this telescope up above a city? The light pollution is absolutely ruining our data. It is making life really, really difficult. We're trying to find planets here, but also all the other science going on up there. And the scientist I asked up there was kind of perplexed, and he said to me, we didn't build our observatory above a city. We built the roads to the mountain for the observatory, and because of that, they built their city underneath our observatory, right? And we've seen this all across California. This is a central hub of astronomy from all around the world. We have all these beautiful observatories overlooking these cities, but it's also very unique conditions for air and seeing in this area. So we're very lucky to have good opportunities to look up at the sky. But I thought that was really, really funny, and I felt really bad for having asked that. But as I said, at the time, we were using the transit method to try to find our planets primarily. There were other ways that you could find these worlds, but the easiest way was literally for us to wait for a planet to pass in front of a star, to see that dip in light, and then to figure out whether or not that's a world. And you can imagine, though, that tiny, tiny worlds are difficult to find around these stars. And it also means that If you have a really, really, really bright star, you're going to need a bigger and a bigger and a bigger planet in order to block out that light. So we've created a situation in which we are finding very few of the worlds. And our technology advances, we get better at finding these worlds, but we really need precision in space in order to help us enhance this. So we ended up putting these telescopes in space. Now, I joke because I was planet hunting for quite a bit there, that the Kepler Space Telescope took my job. At the time, we had these small groups of people at our university, mostly undergraduates who don't get named in the papers. So while I did a lot of this work, no Sarah names in papers. But we launched Kepler into space, and suddenly, instead of people in basements waiting, hoping that a world would pass in front of a star, and then, trying to extrapolate out how long it would take for it to come back around and then taking data the next time. Instead, we could stare up at a small patch of sky and find thousands of worlds in the data all at once. And not just that, they took all of that data because there were literally so many worlds being discovered that they couldn't process all of it by themselves. So they put all that data up online. And I know we're all here in part because we're celebrating citizen science. When Kepler took my job as a planet hunter, I immediately went to citizen science projects online, to Zooniverse, to the Planet Hunters Project, where they were putting Kepler data straight up online for anyone to process through. And it's still up there because even after Kepler, we ended up with the Transiting Exoplanet Survey Satellite, TESS. So I know we heard earlier that much of the TESS data isn't even up online yet. But think about that. We found almost 6,000 worlds beyond our solar system already, but so much of that data isn't processed. So if you're looking for something to do to try to help in this effort, I strongly encourage you to go online and find these citizen science projects and participate, because we need your help. The AI haven't accomplished this yet. We're actually beginning to train the AI off of the efforts of humans. Maybe someday we'll be able to just hit a button and process all of that, but until then, it's an effort so large that scientists alone cannot accomplish it. We need everyone to participate. As of yesterday, and you did hear this from Jesse earlier, we have found 5,933 worlds. So we are right on the cusp of 6,000 worlds. And that is just so insane, because when I started, there were literally none. When I began as a human, we hadn't found any worlds at all beyond our solar system. And it was those first worlds that inspired me. And I mean, I like to think I'm not that old, although I'm getting up there, but it has not been that long. It has not been that long, and we found all of these, and we're right on that cusp of 6,000. And as soon as, and you'll note in this slide as well, there are these two sections for planets that have not been confirmed yet, right? Mostly from TESS. So those worlds we've taken data on, but we're not yet sure whether or not they're actual worlds. They could just be sunspots or something, right? We need to validate that with science. But that is a huge potential. The worlds that are candidates are far more numerous than the worlds that we have actually said exist, which means that this number could explode very quickly. And especially when that TESS data starts pumping out into the world and we all get access to it and people start processing even deeper into it, that number is going to truly, truly explode. So I began my time as host of Planetary Radio literally right before JWST got to confirm its first world. This was, I want to say, my fourth episode. JWST confirms its first exoplanet. This was really cool for a number of reasons. As I said earlier, most of the worlds that we've found are rather large, right? We're finding these Jupiter-sized worlds around smaller stars. But in this case, we actually found a world that was about Earth size on our first attempt. That's wild, right? We could only really do that because JWST is amazing, right? But that is not what I expected at all. This world's called HS475b. While this world doesn't have an atmosphere as far as we know, here I can go, right there. The spectra, you'll notice the spectra is rather flat. If there is an atmosphere here, It's probably so thick that the light from the star can't really pass through it. We think this probably does not have an atmosphere. It's probably just a rocky world. But that's part of what the James Webb Space Telescope does so well that we couldn't really do before. When the planet passes in front of the star, you can detect them by watching the dip in the light, but JWST does something very special. When the light from the star passes through a planetary atmosphere, we can actually study that composition. We can look at how the atmospheric composition of that world is different from the light just streaming from the star itself. So suddenly this gives us the ability to look at a world and tell you what's in that atmosphere. Now, we don't know enough yet to be able to figure out what exactly that means, and I'll show you some cases of that later. But this is an amazing ability. If there are worlds out there that are potentially habitable, we're going to need to be able to do this kind of science in order to do it. So while we found many, many worlds out there, this is the beginning of a new age where we can say, hey, that world has oxygen. That world might have water. This world has something strange that might be a biosignature. This is opening the door to a whole new realm of science that was so far beyond anything we could potentially do ever. But we found this using this classic method, star dip. The team that found this, I was so excited to talk to. I ended up speaking with one of the contributors, but in any one of these cases, it takes many, many people in order to do this kind of science. I spoke with Jacob Lustig-Jaeger, who's an astronomer and astrobiologist from the Johns Hopkins University Applied Physics Lab over in Greenbelt, Maryland. I'm going to share some of the quotes from our shows as we go through. I want to see if this works.
UC Santa Cruz, I went in there undeclared, not really sure what I wanted to major in. I knew, I like math. I knew I wanted to go into some area of science. And a friend of mine said, hey, this exoplanet class taught by Jonathan Fortney looks great. You should take this with me since you like astrophysics. And I was like, I like astrophysics. Yeah, I guess you're right. You're right. Sometimes your friends know you better than you know yourself at times. And that class was an introduction for me to exoplanets.
I thought this was really cool. I knew exactly what I wanted to do really early on. And I think a lot of people that go into space science are kind of like this, right? They catch that bug when they're very small. They watch Star Trek or something and they just never let go. But I think this is a really great example, right? You can go into school and have a vague idea that you like worlds and maybe change course halfway through. This guy, through a friend, decided that he wanted to get into this field. The thing that he's most excited about, and I think this is a defining quality of a lot of people that go into planet hunting, is that they are very curious about whether or not there is life out there in the universe. There's kind of two factions here, right? There are the people that study the worlds inside of our solar system that have these oceans, and then there are the ones that search for planets, and then there are the people that are kind of in the Venn diagram between them, and I've met a number of those people as well.
As an astrobiologist and with a focus on the search for life, that is really thought to be something that needs to be conducted on Earth-sized planets, sort of following the way we think life developed here on Earth and what life requires to exist, sort of takes us to these small rocky planets.
This guy was very lucky in that the first one he found with JWST just happened to be a rocky world. Unfortunately, no atmosphere, but that's okay. As Jesse said earlier, we've found a number of Earth-sized worlds, but none that definitely have these atmospheres on them. So this was a fun moment for me, just right out the gate, with JWST out there in space, finally being able to do this kind of science. And we did see earlier that video of JWST unfolding. I'm definitely one of those people that was absolutely on the edge of my seat. People make this joke about Mars, that whenever something lands on Mars, you have these like 7 minutes of just absolute terror. This went on for days. Every single one of us was totally stressed out. There were hundreds of points of failure in which JWST could unfold incorrectly and destroy a telescope that had taken decades of advocacy and decades of hard work and love in order to accomplish. And thankfully, it went absolutely flawlessly, which is another testament to just the amazing work of scientists and engineers, and one more reason why we should do everything that we can to bolster them and to value their work, because I can't even tell you how amazing that thing is. Actually, this is a total side story, but I got to be at JPL for the unveiling of the first images from JWST. And I cannot tell you how difficult it is to sit in a room full of people that I admire and not ugly cry at an image of the Carina Nebula. I dare you to try it. It was really difficult. So this next episode was from 2023. I called it the Exoplanet Enigma. I don't know if I would call it an enigma exactly, but this world, TOI 5205b, is a large world in comparison to its red dwarf star. Now, this is an interesting situation. Most of the stars out there are smaller, right? I mean, I guess that makes sense, right? It takes less mass to form small stars. You get these red dwarf stars, but they're not necessarily ideal for life. They are very feisty, these small stars. They're constantly just exploding with coronal mass ejections and solar flares. Not a really great habitable place to be. And because of the amount of radiation they're pumping out, they are impacting the environment around them. The reason this one was such an enigma when we found it was because it was a large gas giant orbiting really close to this red dwarf star. Hypothetically, this is not a situation conducive to forming a planet of this size that close to the star, and yet they found it. That's just another testament to all the things that we're still trying to learn about these systems. For comparison, on the left-hand side of this is a scale comparison of the sizes of the stars. So on the left-hand side, that is the star. Underneath it is a Jupiter-sized world. That is the planet we are talking about here. It is about the size of Jupiter. On the right-hand side, imagine this is our sun and Jupiter itself. So check out the size scale there, right? And also Jupiter is way further away from our star than in this case, right? The person I talked to, hold on, it looks like we are getting an update. Apologies. The person I spoke to in this case was Shubham Kanodia from Carnegie. He's a postdoctoral fellow who is exploring these worlds. Shubham grew up in India before coming over to the United States and going to Penn State. I think it's really important to point out that while NASA and the United States is very well known for this kind of space science, right? NASA is the largest space agency in the world. It is the best funded. But part of what makes NASA so special and so effective is that because of this status as being so amazing and well known, people from all around the world come to NASA. They flock to the United States. It is a beacon to people around the world. Sometimes people go back to their native countries and they spin off whole new space agencies. But this is another reason why we should be valuing NASA, because it is inspiring and giving opportunities to space scientists all around the world. He, in particular, got into space science and got into exoplanet detection, but he was primarily interested in these interesting situations with the M dwarfs.
I've always been interested in exoplanets, and what we realized is when I got to Penn State, there's a niche that hasn't been fulfilled yet, and that's to study M dwarfs. So M dwarfs are basically stars that are like the sun, but they're much cooler than the sun. So the sun, for reference, is something around 6,000 degrees, whereas M dwarfs are about half of that in temperature. So they're much cooler, much redder, they're much smaller than the sun, so they're extremely faint. But the interesting thing is they form like 75% of the galaxies, so there are like hundreds of billions of M dwarfs out there. But because they're so small and red, and because the Earth doesn't run an M dwarf, traditionally they have been ignored when it comes to planet studies.
It's really interesting that so many of the worlds out there are this kind of star. But this world that he found in this case was so strange. It was literally blocked 7% of the entire light coming out of that star. So he was very puzzled, but I loved getting to speak with him. After that, we kept on with some JWST investigations. Honestly, most of these come from JWST, although the world in the last story was from TESS. In this case, we found one that to this day, people are still asking me about, this world called K218b. Now, this one's really interesting because it's part of this idea that people are kind of percolating on. Most of the worlds that we've found out there are sub-Neptunes, right? They're that size of world, that class of world that does not exist inside of our solar system as far as we know, unless we find Planet 9, but that's a whole aside. But this world is potentially something very close to this idea that people are calling a Haitian world. It's a portmanteau of the words hydrogen and ocean. Essentially, they're looking for worlds that have liquid water oceans on the surface, but might have these atmospheres with hydrogen built into them. But this one, when they looked at it, absolutely threw people for a loop, right? If you look at this spectra, we see some things that are very well known here on Earth. Methane, carbon dioxide. These are things that Earth needs, that life needs. But the really weird one, although they're still trying to figure out whether or not this is an actual detection, so don't freak out, is this thing called dimethyl sulfide. Now, here on Earth, dimethyl sulfide is produced primarily by living creatures, primarily small creatures living in our oceans. There are some processes that can create this outside of that, mostly factories and things like that. But that's wild. That is a potential biosignature detection on one of these worlds, a world that might have a liquid water ocean. That's phenomenal. The person I spoke to in this case was Nicole Colon. She's an astrophysicist at NASA's Goddard Space Flight Center, but also the deputy project scientist for Exoplanet Science at JWST. I love that I can just like call these people up and they say yes. But she was a very fun person to talk to. Some people are very science, but she was just an all around good time.
I remember when I started graduate school and I wrote my first paper as a grad student. In the introduction, you always talk about the current state of exoplanets. And I think it was literally fewer than 20 transiting planets at the time. And I could tell you something about every single one of them. You know, I knew all their names, their properties, right? Everything. With 5,500 plus planets, I can't do that now. There's no way. We are searching for life, even if we don't mean to do it. We're doing it all the time. So it's a matter of, expanding our horizons a bit. Like, we know of Earth having life. Obviously, we're here, we're talking on this podcast. There's life here. But that's life as we know it, right? So we do have to think outside the box. What is life as we don't know it? And that's where astronomers have postulated this new population of planets that could be potentially habitable, even though they are in this unique size, mass, density range.
I think too that what our solar system is showing us is that we have one rocky world that has life on it, but we have many ocean worlds. And I often wonder whether or not, as we're looking out there, if most of the life out there actually lives underneath ice sheets. That would be a harder thing to figure out though. And then came this moment. This was a year ago. We hit the 5,500 mark, and I had Jessie Christensen, who was on earlier, as my guest, because she is the woman in the world that has discovered the most exoplanets. I think that is absolutely phenomenal. That is so amazing. I had to have her on the show. I want to share something that I don't think she had time to talk about a little bit earlier, but she actually hosts a podcast dedicated just to talking to people who have discovered exoplanets. Most of my shows are about things all over the map. I have spoken to people clearly who have discovered exoplanets, but if you want a podcast dedicated specifically to talking to the people that explore these worlds, she is definitely your person. I spoke with her a little bit earlier too. She comes from Australia, but actually the way that she ended up working at NASA was because she was working down at the South Pole, and someone there was like, "Hey, you want to work for NASA?" And she said yes. I think this is something really important to point out to people who may be younger or people who are interested in getting into this field. Your opportunities will open up wildly when you speak to people about your passions. Not all of us end up with opportunities just because we apply to a job. A lot of it happens because you went to that colloquia, you spoke to that person at a talk like this, right? When people reach out, you find opportunities, and I think that's really important. Part of how I ended up with my job at Griffith Observatory was because when I went in for my interview, I spoke with Dr. Reitzel, and I said, "Oh yeah, I did research with Alex Filipenko." He knew him. And because of that connection, because we all vouched for each other, it opened up opportunities to me, and I may not be here, I might not have been here today if I hadn't opened my mouth to say that.
She would have gotten the job.
But Jessie introduced herself earlier, but she is NASA's Exoplanet Archive and NASA Exoplanet scientist, or project scientist for the NASA Exoplanet Archive.
When I started university, I didn't think I would look for exoplanets, actually. I started a biotechnology degree, which very interestingly, given the direction of exoplanets, might come in handy at some point, given that we're starting to think about things like biosignatures. But yes, I didn't think about exoplanets at all until I was at college and realized people were doing it. People were finding exoplanets around other stars. And I was like, oh my gosh, that sounds like the coolest thing one could possibly do. I want to do that. Basically, every time we can peel back another layer, we're surprised. And that's just, as a scientist, that's just joyous, right? You're just like, oh my God, of course nature has a better imagination than we do. Look at all of these incredibly different and interesting planets we found.
This is the last world I'm going to talk to you guys about, TOI 270d. Right now, I think we're very, very interested in trying to understand sub-Neptunes as exoplanets, primarily because we don't have any inside of our backyard. There are none out there that we can look at closely, unless Planet 9 exists. I have to keep caveating that. Even if we did, though, it'd be so far out there, it'd be a little bit difficult to study. So what we do is we try to study these sub-Neptunes outside of our solar system to learn a little more. This one, TOI 270d, is an interesting world because it basically, we think it might be a lava world, but it's also in this range where it could be a Haitian world. There are these worlds that we're studying that are somewhere in between we don't fully understand. We need to look at the spectrum more in order to understand them. This was basically what they thought was going on here. It has a thick atmosphere. And then underneath that is this magma ocean that is heating the atmosphere to hotter than the surface of Venus. It is thousands of degrees down there. The person I spoke to in this case was Chris Klein. He's from the Southwest Research Institute. This guy I had spoken to before, not for exoplanets, but because he was one of the people working on the project to learn more about that ocean moon Enceladus and what we had learned about the composition there. He was on the team that found the phosphorus in the water. Phosphorus is really important. It's a key ingredient to life on Earth, which is why that was so interesting. But he's also looking at exoplanets out there to understand more as well.
Love to try to connect the puzzle pieces. It's great fun, and I think it can be powerful in opening our minds up to more possibilities. I think we'll be shocked when we learn what's possible on these other planets far away. Things we can't even imagine may very well be happening out there. The unknown unknowns, and that's actually what drives a lot of exploration. What drives exploration for many people, including myself, is not to confirm our hypothesis, but we just go out there because we want to learn more about the universe and the solar system and what's actually possible.
I think it was a famous quote from one of the Planetary Society's co-founders, Bruce Murray. Someone asked him, what do you think we're going to find when we send missions to these worlds? And he said, we don't know what we're going to find. That's why we need to go there, right? Yeah. We make these discoveries that would absolutely blow your mind, that are so far beyond what we could ever anticipate. And we can only really do that by exploring things that we don't fully understand. So I've learned a lot of things from talking to these exoplanet seekers and from my own motivations as well. But just to kind of crystallize it, stay curious. Sometimes things are going to be so far beyond what you imagined. Embrace complexity. Sometimes that spectrum is not what you thought it was. Please always get validation. Be hopeful. Sometimes you're going to find things and it's going to blow your mind, and the chances you take in life are going to alter not just your own life, but perhaps the face of what we know about the universe. And also inspire and encourage young people. Many of the people I spoke to in these cases were inspired as young people, even if they didn't decide what career they were going to go on until they were actually in college or they were on an ice sheet in Antarctica or something, right? It was those moments when they were kids, when they were watching Cosmos or watching Star Trek, or because someone took them to a place like this or gave them a citizen science project and tried to inspire them. I think those of us that are already in the field are very passionate about this, but there's a whole new generation that is about to have opportunities so far beyond anything we ever dreamed, especially if we can get that Habitable Worlds Observatory out there. So please, if there are any young people that you have in your life that might be interested in this, do what you can to encourage them and give them the opportunities, because we're going to need them to process through all of this data and unlock the next, the next generation of these exoplanets. Thank you.
Any think we can take a couple of questions here.
Don't want to take everyone's time, but
Yeah.
if anybody has questions,
Couple of questions. for
either about
Sarah.
exoplanets or about podcast creation or about talking to weird space people, I'm down.
Your exoplanets, do you have a catalog?
Yeah. Absolutely. Gonna go backwards. Yes, the NASA Exoplanet Archive. This updates all the time, even in places like Griffith Observatory. There are places down there that update because of this archive. You can go in here and look up all of the exoplanet discoveries.